This is the PowerShell Podcast.
Most of you know the PowerShell Podcast is sponsored and made possible by PDQ. I've had questions from listeners asking, what's PDQ and what do you do? Well, we help IT teams automate endpoint management. PDQ Connect is our cloud-based tool for real-time software deployment, patching, scripting, remote access, and vulnerability management. It's fast, flexible, and built for people who just want things to work. If you want to see it in action, head to pdq.com/podcast and check out our interactive demo. No signups, no emails, no credit card, just a fast and easy way to explore how it works. That's pdq.com/podcast. Automated endpoint management that doesn't slow you down.
Listen up. Welcome to the PowerShell Podcast, the podcast for PowerShell and the PowerShell community. And now, here's your host, Andrew Plaw.
Welcome to another episode of the PowerShell Podcast. I am your host, Andrew Plaw. That's at Andrew Plaw Tech on all socials. Check me out there. And we have a very special episode today where we're going to talk about turtles. Now, what do I mean by that? Oh my gosh, I've piqued your interest. Quite the hook, right? We love animals here. Well, today I have James Brundage joining me today. James, welcome back to the podcast.
Thanks.
What on earth does turtles have to do with PowerShell, man? Where's the connection there?
Well, there's a very old connection and a very new one. So let's kind of talk a little bit about the very old connection.
Let's do it.
And what the hell Turtle is. Turtle's this graphics mini language, basically, that was first written in 1966. It was basically what helped get us to the moon. In a weird way. Okay. Turtle was built first in Logo, and Logo is built around easy text interpretation, easy parsing, and verb noun pairs. Okay. So the very old thing of what Turtle has to do with PowerShell is that PowerShell is kind of like the great grandchild of Turtle and Logo as a programming language, right? It's like what has happened with that concept as it's iterated out through that branch of the language family tree, essentially. So PowerShell kind of comes from the languages that are more mathematically oriented, those functional languages. That's kind of its probably greatest lineage. It has aspects of object-oriented programming. It has objects. You can do amazing things with them. We all know and love the object pipeline. But the way that its syntax works is much more akin to a functional language. And those languages were always built for easy processing of a lot of math and graphical display of that, so that we could basically understand the mathematical universe a little bit better. So that's what Turtle used to have to do with PowerShell. Now, I've kind of known about this for a very long time. Both like the whole PowerShell relationship to Logo, through various like bits of wisdom and Jeffrey Snover. And also Turtle itself is something that I kind of ran across at first when I was like 5 on Apple IIs. It was a more common thing. It's also something you can find a lot of tutorials on for Python. There's a good Python module for Turtle. It's, I would think, not necessarily as good as what I've built, because what I figured out about, I guess, 8 weeks ago now is just how fundamentally simple Turtle is. What you're doing is, imagine you are a turtle kind of holding this pen, right? You can change your direction, you can rotate, and you can move forward, and you can pick up and put down the pen. That's how you draw with Turtle graphics. So you calculate everything relative to essentially where you are, right?
A cursor, or the turtle, so to speak, right?
Yes.
You're guiding the turtle to make all these intersections to draw a pattern or something.
Exactly.
Is what you think of, right?
Yeah. So one part of it is rotation. Well, that's really easy. I could just, take a number and say that's my heading, right? That I'm, heading 90 degrees, heading 180 degrees, heading 60 degrees, so on and so forth. Heading even at a sub-fraction of a degree. Turtle doesn't care. Turtle just, turns this amount, and now it's heading that way. So that's really easy math. That's just plus and minus. Forward, the other fundamental thing, is really easy too. You basically, the thing you're looking for if you're kind of looking on the internet is a polar coordinate. But a polar coordinate is basically saying I'm at the center of the circle. I'm at this angle. What is my radius at X and Y coordinates at this exact point in the angle or in the circle, right? So if I have this radius and I have the circle, I can basically say, here I'm going to draw any number of shapes and, just kind of rotate around that circle. And that's both how Turtle works and say how Spirograph works, right? So figuring out how you move forward is pretty easy. Figuring out if you rotate is pretty easy. A thing that I had learned along the way is that you have relative points in SVG graphics paths. So if you're drawing a line in SVG, which is a web standard that's been around since I think 1999. But if you're drawing a line in SVG, that line is describable both in absolute terms and in relative terms. So I can say I'm going to draw a line to pixel 50/50, or I can draw a line to 50 pixels from here and 50 pixels from there. Right?
This is PNG we're talking about, right?
Graphics, SVG.
SVG, sorry.
The major difference between PNG and SVG is that PNG is rastered. You do the math, you get a point, it's at the set resolution, that's it. You cannot scale it. SVG is scalable vector graphics. So when we're drawing a bunch of points, we could make those points as big or as small as we want to be.
So they have to be relative to each other kind of thing.
They don't have to be. You could still do this with an absolute point. You're just drawing a number of points and lines between them instead of drawing an image pixel by pixel, which means if you scale the lines that you're drawing, you can blow it up or shrink it down to infinite proportions. That's the scalable part of SVG.
Yeah.
So bottom line of it is, if I say the turtle is going to move forward 45 degrees, I can basically use the, simple polar equation, basically cosine and sine of my heading to figure out where I'm going. And that's, going to be basically the square root of 2 in some direction, like at 45 degrees along the curve. So I can know how to move along a distance, right? And make any number of shapes just as if I was that turtle, right? And you can build.
This is a fast turtle, to be honest, right?
That's pretty fast. Sure. The PowerShell code that builds it is pretty fast. You're basically asking the turtle to draw all the points infinitely quickly and then go from there, or as quick as it can. I'm bringing up an examples page now, and kind of one of the places I kind of start with is basically like, let's draw a triangle. We do that by rotating 120 degrees, going forward 42, rotating 120 degrees, going forward 42, rotating 120 degrees, going forward 42. I mean, even if you're just listening along, this kind of makes sense, right?
If you're good with shapes and math a little bit, yeah.
Yeah. And it's very easy to kind of experiment and find out. You can just basically copy and paste these instructions in. And you can almost feel the PowerShell-ishness of Turtle when you use it this way.
Yeah. In Turtle, it's a DSL, would you call it?
sort of. I think it's more of a convention for the way you think about this sort of a problem. But there are a few popular implementations of Turtle through the years. There are a couple for robotics. I don't remember the name of them right now. And there's a Python Turtle that has been around for any number of years. The Python Turtle is almost kind of like a full mini app and is producing more raster images than vector images, and also is more primitive. I don't mean to be any degree rude about it. It just doesn't have as much additional functionality layered in. Because essentially what this turtle is saying is basically, I'm going to treat any given method on the turtle object as a move. I can implement forward and rotate. That's easy. But I could also implement polygon, which would just take, the number of sides, divide 360 by that, and draw a line forward and, rotate n number of times. So that'll let me draw a pentagon, that'll let me draw a hexagon, that'll draw a septagon, that'll let me draw n number of n-gons that I don't know the names of.
So within your turtle project, you have support for these shapes. So we wouldn't have to define the walk forward, turn 33 degrees, walk forward. That is predefined whenever you say polygon. You've taken care of all that extra work
taken care of for you. And that's something that I'm continuing to enjoy and explore. So at this point, it's a pretty rapidly growing module. As I'm like, oh, here's how I can do some cool new thing. Because this sort of stuff kind of helps make various parts of the programming and real universe fall into place. It's very easy to kind of see, say, fractal math if you're providing the inputs and are able to understand how it's built from top to bottom. And it's very easy to see why they call it sacred geometry when you look at some of these shapes. I'm just going to scroll ahead for a second to show off a flower and then a morphing flower. So you can basically draw all these basic shapes. You can go ahead and copy a shape n number of times as you go around a circle. That's called a flower. So it's like I draw a square and then I rotate 45 degrees and then I draw another square and then I rotate 45 degrees. Right?
Yeah.
So you get all these beautiful shapes this way, and that's built in with turtle flower. And you get this beautiful shape with a number of intersecting grids around it, and inside of it, a number of lines that intersect all at the center. So you get this really beautiful shape, basically just out of making a flower.
I mean,
saying turtle flower.
Like literally when you saying turtle flower, that's actually what you would type into PowerShell. Turtle flower, and then you type into
PowerShell, and then you'd get it. Now it's going to spit it back out. Here's your heading. Here's your size. You can go ahead and save that to a PNG, or you can put it in double quotes, and it will give you the SVG. Or now you've got me mixed up. Sorry, you can go ahead and save that to an SVG, and you can also put it in double quotes and put it into a SVG string. So you can basically drop it right into a web page just by double quoting it, which is exactly how this web page is being built. So every one of these examples is basically being emitted directly from PowerShell, coming out, being stringified, and thus turning into SVG, which is a really easy, simple trick to HTMLifying any object you'd like in PowerShell. Just side noting there. So, yeah, go ahead.
James, I've played with this turtle quite a bit. In fact, last week you joined us for a PowerShell Wednesday, and we'll have a link to this in the show notes, where you gave us a full-on presentation. So if people really want to dive in deeper and see more of an in-depth demo, I'd say checking out the documentation is actually going to be incredibly helpful for this particular project. But there also is that presentation if you want to dive deeper. And I think there was some wisdom shared. I think there's something interesting about this topic in that it is, this PowerShell podcast. I talk to a lot of people who are trying to learn PowerShell. So it is in the PowerShell space, like we're running commands in PowerShell, but what we're getting is something a little bit more interactive, which I look for in all beginner kind of projects. You want to give them something that's fun and interactive. And I really think this might be a project that's well suited for people who are just looking to mess around with PowerShell and get some more fluency, right? Just get yourself in there, making files, moving things around,
I
opening
think
them
you're
up.
right. I mean, I think that's also kind of part of what I was trying to do when I built it, is like reconnect with that joy of my youth and share it in and through PowerShell. Basically try to take the thing that had, before I even really knew what programming was, inspired me to learn to program, and try to bring that into the modern age as best I can in a PowerShell syntax that is really easy to use. Because I do love building some really easy to use PowerShell. And just to kind of cover the bases here, the main command you're going to use with turtle is get-turtle, but you're almost never going to call it that because it's got the alias turtle. So when I say to get this beautiful graphic, all you need to type is turtle flower, yeah, I mean it. If you want it in a web page, you put double quotes, dollar parentheses, turtle flower, double quotes. There you go. You've got an embedded beautiful flower in your web page.
Yeah, and that dollar parentheses thing, that's called like a sub-expression, I believe. So it allows you to
That
run
is correct.
PowerShell code inside of a string, technically, double quoted string.
Yep.
Yeah.
And if I wanted to treat it like an object still and basically say, okay, hey, flower, how wide are you? I could basically assign it into a variable, turtle flower, and then $t.width, $t.height. And I can get what it would have as a calculated width or height. Because it's just a little turtle going around in infinite space, mapping, I'm moving this far to the left or up, I'm moving this far left or right. Actually, this far left or right, this far up or down. So, yeah, you could build any number of shapes that way. And basically, that's how math nerds built out the first data visualizations and how data visualizations are built to this day. I haven't added this to Turtle yet, but it will be coming. You can kind of almost intuitively see how I might draw a bar graph, for example. Like, let's take that simplest case. I've got, let's say, 4 bars to draw. I can either just take their absolute data and turn them each into a forward that, or, rotate, then forward this amount, and then over a side, and then back that amount. Or I can change up the width too, right? So give you some sense of scale as I fatten or shorten the bars. And I can draw that whole bar graph just as a series of turtle moves. I can do the same thing for a line graph in theory. I haven't gotten my turtle scripting just right. I haven't gotten turtle power honed yet. I'm learning this again too. And I'm loving what I learned. Yeah, there's just a lot you can do with this. Like almost anything in programming and many things in mathematics, there are literally an infinite number of possibilities you have here. And unlike many things, this is one of those cases where it's easy to see, feel, and work with the infinite. So you can very easily iterate on something any number of times to kind of see what it looks like if you just changed a little bit here and there. And this gives you a lot of possibilities in terms of learning and understanding. You can also turn one set of points into another. This is actually a capability of SVG animations. So you can do what they call morph. So, you can basically say, here, I'm going to take a flower of a random number of sides, and I'm going to take another flower, and I'm going to basically morph from the first flower to this randomly rotated flower to this other flower and get this absolutely beautiful shape that just sort of folds inward on itself as all of the points rearrange.
It is pretty cool. I definitely can confirm. Check out the video version on YouTube if you want to see it for yourself. But so I'm curious though. I've followed along. You say SVG supports the morphing, so you didn't have to write anything in particular for that?
No, I just gave it multiple points and put it on a animation.
Wow. Huh.
And I think I've got a pretty good default for time span, but you can just set the duration by saying turtle duration 10.
Gosh, it's kind of wild to see this project because I think I remember you doing SVG stuff quite a while, like maybe
I have been
ago.
doing SVG stuff for a bit. That's part of like how I've gotten to this point of understanding with it. I'm actually going to give a weird shout out to the Blue Sky logo for helping me kind of understand a critical part about SVG paths there. The Blue Sky logo is actually pure SVG, and it's built almost all with relative curves. And so that was how I was like, oh, I can do a relative point in SVG. And then I had some fun kind of constructing some stuff from there. So I've got this mrpowershell.com/SVG mountain range. It's a real simple example of the technique here, where I'm basically just drawing a line X number of pixels up or down, and I'm picking up or down randomly, and then I'm drawing a couple of them. And I get the illusion of a mountain range. Every new build, I'm getting a different mountain range. Real easy example to throw together. And let me kind of connect these dots more significantly, because this is actually really cool the more we get into it. From a certain point of view, insert Star Wars meme here. Basically, many things are turtles. They're already implemented as turtle-like short languages. SVG paths are a good example. You've got a constant like M or L that says move or draw a line, right? And then you have a couple of points. Okay? So it's a short form of turtle. Another thing that's a short form of turtle is G code. And that's how you do 3D printing or etching a shape with the CNC machine or laser cutter. Does this all kind of sort of make sense?
Mm-hmm.
So yeah, there's basically turtles all around us. If you go more metaphysically crazy about it, one of the examples I think I brought up last week was that we are, on a fundamental logical level, turtles wandering around our universes. Okay, I'm gonna go sidetrack for a second. One of the most inspiring parts of this journey of discovery of re-implementing this whole thing was going and purchasing a very old book on turtle. And I can try to provide a link in the description. It was written in 1980, so it's actually a little older than I am. And the copy that I got came out in 82. And it is so bloody old, it had a punch card in there as a bookmark.
Wow.
So this is actually the first time I've seen a punch card like IRL, at least since I was much younger. And it was quite the blast from the past. And I kind of bought it just kind of figuring, oh, I'm going to get some pretty shape inspiration. Cool. That's like chapter 1. By chapter 2, it's starting to talk about how kind of turtles are used for behavioral modeling and basic AI. So if you are a turtle looking for another turtle by sight, right? There's nothing between you and that turtle. You can see this turtle. I know exactly what heading I need to turn to approach you. If I'm trying to catch up with you as a person walking down the street, I'm doing the exact same thing. I'm turning to approach you, and I'm increasing my velocity to try to match, right? So we're all basically doing this sort of turtlesque math in our heads all the time without even thinking about it. And yeah, this is how 70s and 80s computers were able to basically go model behavior of, say, species by basically saying, all right, well, if I was hunting by sight, this is how I'd hunt. If I was hunting by smell, then I basically can tell vaguely what direction you're in. Like I've got like some bit of your odor out to a radius, right? And within that radius, I could theoretically smell you're in this direction or that direction, and I can reduce or increase my radius. If I'm looking for something in my apartment that's burning, I'm smelling, changing my head direction, decreasing my radius, going, oh crap, where's the fire extinguisher? Right? You guys all hopefully get the idea. This is a really good way to model things. It is, as the old joke goes, turtles all the way down. And that's just chapter 2. But I think like chapter 3 or 4 or 5, it's into like 3-dimensional turtles, which are a thing, and I will be getting to eventually. But yeah. By the end of the book, it's talking about how turtles can be used to model general relativity. And this is so far beyond what the hell I thought I was getting into when I bought that. And it's obviously going to take some time to get there, but it's also almost intuitive how it would work. Because if I imagine I am a turtle marching into the wind, right? The wind is facing exactly at me, right? So the wind is trying to say, I am going to go back whatever percentage of a step every move. And if I step, I can move less because I'm having to overcome the force of the wind. And if I have 2 points attracted by gravity, you're talking about, well, what's the force from one attached to the other? And I move each of the turtles closer based off of that point. But because, they're moving towards each other at that point, that also induces rotation as they both try to approach each other an angle or an optimal angle. So you can basically model the literal universe using turtle. And I did not expect this to be a side effect of this new PowerShell experiment. I think this will be a lot more fun than just the pure SVG stuff. It is kind of worth kind of noting for a second, though, that this is all possible because of a very powerful part of SVG and of modern graphics, basically the SVG path. So you have this kind of little bit of G code. There's about 8 commands in it. We're only using basically 2. But, that describes motion around a plane. And this is how you can draw a path in SVG that isn't just a circle or a rectangle, but any shape you imagine.
What's the G code mask?
Graphics, scalable vector graphics.
G code. Okay.
G code.
Yeah.
This is probably best half explained by Wikipedia. So let's go ask Wikipedia. Yes, actually, I didn't even remember this about it. It is an abbreviation for geometric code.
Oh, nice.
Which also kind of explains it, right? It's almost there in the name. Because what we're doing is a bunch of geometric code. And
a lot of these concepts are new to me, but I'm following.
Yeah.
They're clicking into a good spot in my mind.
Cool. So here's, as I understand it, I am not, 3D printing super expert. I dabble, but that's it. As I understand it, what's going on with 3D printing is that you're taking a shape, right, which is defined as a series of triangles, and you're slicing that shape into G code. which is the thing that the 3D printer actually speaks. There are a bunch of different well-known variations of these G-code instructions. I think rip-wrap is one of the more popular ones. And it will say basically, move forward, go along this axis, deposit or extrude stuff or not, right? Yeah. And
turtles.
Yeah, turtles all the way down. I was actually thinking about this sort of 3D problem a little bit earlier. If I wanted to print a toroidal fan or design a toroidal fan, right? That's actually kind of a problem that, I don't know, I didn't know how to even begin approaching until I started seeing the turtles all the way down. But now let's kind of think about it for a second. I mean, I draw a circle and I draw a number of spokes, let's say 5, right? So draw a number of lines at angles, right? And, you know, so they draw turtle circle, whatever radius, you know, forward or rotate 90, forward, whatever that radius, rotate, side count divided by n, or 360 divided by side count. And, you know, then I've got the 5 spokes, right? And then I take that shape, and if I were to go imagine it layer by layer, I'm taking that shape and I'm turning it just a little bit. Every layer, as smooth as I can make it, I'm turning my spokes. And what do I end up with? I end up with a propeller blade that has a constant curvature, so it's very efficient. And bada bing, bada boom, toroidal propeller. So I don't know how perfectly this will work. I have yet to go design the shape that way, but just by being able to think turtles all the way down, I'm able to kind of realize, holy crap, I can build this sort of thing just by basically depositing layers. And yeah, turtles beautifully insane in all of the best possible ways. Like, it's very mind-blowing and unexpectedly beautiful, and like really helpful in understanding a lot of fundamental concepts, even if that's not what you're aware that it's doing.
Yeah, no, it definitely peels back the curtain on some other stuff. And it's kind of interesting in a certain way because we are technologists. And this is kind of like foundational stuff for a lot of what we use every single day. So it's kind of cool that we get a little bit of an insight into it.
Yeah.
The math stuff is wild.
Yeah. Well, actually, that's still the best part about it, because I have a love-hate with math, as I'm sure do all of you. And I don't really have to learn that much pure math. I'm just kind of like, you know, most of the math is done in the forward and the rotate. In fact, the math is really done in the forward. Like, I'm just figuring out that relative position, and that's really well-known math. Everything else descends from basically, I'm going to say move forward, I'm going to say rotate this many times or in this many ways. And that's just for loops. You know, that's easy stuff. So, yeah.
As a wise young man once said in a news broadcast, I like turtles.
I believe that is a meme that will be called back to many a times. Also, if you're putting out any posts on this, please let's help hijack hashtag turtle power.
Turtle power, all right.
Yeah,
some memes there. I have to include a couple memes for the listeners who listen every week and know me. I feel like we're friends, so I got like, you know, refer to things and give them a little wink at the camera.
I feel like there's probably quite a few memes that can be made from turtle, but you know, we'll see how that evolves over time and
it's there.
What horrors I have begun to wrought.
I have a challenge for the audience. In fact, I've prepared 2 challenges. Community challenge. 1, check out Turtle. It's free. There's not really a sales pitch to go along with it, other than it's cool and you can check it out. And I highly recommend, if you're in this PowerShell learning thing, it is a low risk way. You don't need an AD environment. You don't need anything. You just play around with images on your machine. It's a great opportunity to deal with creating images. You can run invoke item on the SVG that you create to bring it up in your browser or whatever. You can delete the images afterwards. It's great for beginners. Also looks really cool. There's a high end. 10 out of 10 recommend its documentation because you can see like the image that you'll create, and right above it is the code that does it. and you could see the actual PowerShell code that is used to build the site as well, which is sick. All right, that's number one. Get turtling up. Number two, PowerShell Wednesday. I need more speakers. Hit me up. We're always looking to provide new opportunities to new speakers and also returning speakers, MVPs. Hit me up all the same. We have PowerShell Wednesday every single week at 2 p.m. Eastern. Back to the turtles, though, my friend James.
Yes.
Kind of wild. Did you know what you were getting into with this whole journey? You bought a book. Did you buy it online or did you like
I bought it online.
Bookstore on the okay.
It came from a dusty bookstore in Atlanta.
It fell from the top shelf and hit you and you said, "What is this?"
No. That would be great. But no, I don't remember exactly which site had to kind of connect the dots that it was just, forward and rotate.
Yeah.
This is something I've been aware of for a while and kind of vaguely wanted to do, but didn't really quite know where I would start until the two pieces fell into place. And then it was off to the races. It is off to the races. It's something that I've been having a lot of fun with. The other kind of driving force behind it and thing that we haven't talked about too much is that I've been building a lot of very dynamic static sites in PowerShell. That is to say, I'm using a GitHub workflow to run a build PS1 that will do whatever I would like. And this approach is very open and flexible and lets me kind of generate a large number of web pages on the fly programmatically with a language I'm familiar with and very little effort, because essentially all I'm doing is I'm redirecting output or piping and redirecting output. So if I've got like 50 different parts of a web page, here's a tag, there's a closing tag, there's an opening tag, there's some stuff in between. All of this can be piped in to a file directly, and there you go, you have a web page. So I can just write a script that farts out HTML, and that produces a web page. That's it. And I've been having a lot of fun with that. And I wanted a general purpose tool that I could use to draw in that context. Because, pictures speak 1,000 words. I also had done enough with SVG to know that it was capable of it. There is a really good project that I have been building for a few years called PSSVG. It is basically a wrapper of the whole SVG standard. The thing of it is, the more you know SVG, the more you understand that you can do almost everything through paths. In fact, I wouldn't at all be surprised if everything within SVG that is not a path is under the hood implemented in paths, because they are a very good flexible way to describe stuff. And it got to a kind of a point where I was like, I've got all of this stuff for everything in SVG and some of this stuff that is math and path related. But it didn't feel like it was the right package for that. It felt like I wanted something that was easier for the math stuff. Like, I'm still not quite there, but I basically want to be able to throw a bunch of points at a PowerShell script and get something useful. I want data visualization to be very easy for us all in a way that'll be portable and work within web context and, outside of it. So, yeah, I kind of knew the lingua franca I was going to be able to use, which is SVG paths, figured out that they were relative, thanks to the Blue Sky logo, and figured out, thanks to a few random articles, that Turtle was as simple as making a relative path from point A to point B. So, okay, I know how to draw a relative path. I know how to go around a compass rose and draw it at an angle. All I need to do is just keep drawing relative paths at an angle. And if you want to get a little technical about it, all I need to do to know how big I am, thus to how big to size this by default, is just keep count. Okay, so I'm starting at 0, 0. I go this many positive and this many negative. Those are my bounds, my minimum and my maximum. I know how big I am. And if we're getting extra mathy about it, I might not know your precise area at that point, but I definitely know the upper bound of your area. Does that make sense? Like,
vaguely.
you will fit within this rectangle. I know because the outer edges of this rectangle are defined by you. So you will exactly perfectly fit inside of this rectangle. Therefore, the upper bounds of how big you are this rectangle. Does that geometrically make sense?
I think so. Checks out.
Yeah. And again, this is not stuff that I really as implicitly understood even a few weeks ago. I'm learning a lot as I go just in how these shapes are constructed. And I'm trying to include as much of that learning in help as possible. I'm also working on getting some better resources for the PowerShell web dev stuff together, because that is a fantastic trip that we should dive into a lot more. But again, you can just write a PowerShell script and output HTML, and bada bing, bada boom, you got a web page. You want a standard layout, pipe it to a standard layout, and you got a web page. All right. You want to add some standard metadata, create a site or page variable, add some standard metadata, and you've got a web page. Blowing your brain a little bit more, you want a dynamic JavaScript file that's got your JSON output of a given PowerShell query that gets all your processes. Go and take 3 or 4 properties from getProcess, convert to JSON, stick it in a file that says export default that. Congratulations, you have a JavaScript module that has your data that came from PowerShell. And so PowerShell is a really, really great meta programming language when viewed through this simple lens. And that is basically star.star.ps1 redirect to star.star. So if I am index.html,
redirect is like the greater than sign?
Yes.
Yeah.
I feel bad, especially after all of this, sheepishly bad. Because as much as I'm showing some math nerdery here, I'm literally always, which one's the greater than and the less than? In my head. Anyway, yes. You're redirecting into a given file, optionally piping into a layout first, or piping into something else that would transform your code. And this opens up easy meta programming of any language, including HTML, within PowerShell and within workflows. So you don't really have to even be a super PowerShell wizard to do this. You can basically be like, if $true, do this one thing and go, for instance. If false, do this other thing and go. And the same principle applies. You're just going to end up with a Go file that has your combined code of all the conditions that were true or false when you generated it. So really easy to parameterize all of this stuff. Actually, it's one other thing we should briefly highlight here, especially for the people that aren't watching this online. One of the really cool things you can do in PowerShell that not everybody knows is multiply arrays. Did you know you can multiply an array?
I mean, I would assume you could, but I don't think I ever have, not once.
Okay.
It hasn't really been something I've thought about.
So if you have a list of, say, steps, right? Then I can multiply that list by just star number.
Yeah.
So same way as I would multiply a number. This also works for strings. So if you wanted to repeat a string 20 times, you could say string times 20.
Yeah. I've done that kind of thing before.
Cool. So same principle, right? But that means that all of our shapes here, you're like, do I have to really write out all the steps each time? No. Even if you're building it by hand, you could write it as something like forward 10, comma, or forward, comma, 10, comma, rotate, kind of, comma, 120 times 3. And that'll also draw you a triangle. And going all the way down to the very cool things, this works at the opposite end of things. Let's scroll our way down through the end of this here. One of the most fun parts of this discovery journey has been finding something called an L system. You can get this on Wikipedia. It's short for a Lindenmayer system. And these are systems that describe growth of a shape over time. Okay? Basically out of a simple set of rules and repeating that simple set of rules. So you take a string, you multiply the string, essentially. Take a list of instructions, multiply the list of instructions. So there are a number of well-known fractals. The turtle knows how to draw an L system. it was very easy to basically copy and paste their examples. And now we can draw all these pretty fractals, like a box fractal or a board fractal or a crystal fractal, a ring fractal. This one I found last week, it's called a pentaplexity. It's like a bunch of pentagons overlapping in interesting, beautiful ways. I actually made this one in my experimentation. I call it a triplexity, which is like a triangle with a little spur that you keep rotating and repeating. There's the cock island, cock curve, and cock snowflake. No, funny jokes. He was a very respected mathematician. There is the Levy curve. There are things that are used to make microprocessors and fill space, like the Hilbert curve and the Moore curve, like that Moore. There's binary trees and fractal plants, and there's arrowhead curves, and then there's classics like the Sierpinski triangle. And what we can actually do, if we want to make really cool shapes, is we can take these fractals and we can rotate and repeat them. One of the things that I figured out very recently, like the past 48 hours, is that from a mathematical perspective, backwards is a reflection of forwards, or forwards is a reflection of backwards. So if I want to draw this triangle reflected onto itself, I just give it a positive number followed by a negative number. So I'm saying turtle, go rotate 60 degrees, then draw a Sierpinski triangle, 42 length of each time, order 4, meaning repeat your shape 4 times before you're done, and then draw the same triangle at negative 42, 4. And I get this Sierpinski rhombus, I guess I'm going to call it. And I also can rotate the triangle and get these overlapping snowflakes that I don't even know if I have the words to describe their beauty. But I know I'm like early for Christmas. So yeah, there's just an amazing number of beautiful shapes that you
Genuinely
get out of this.
These are not shapes you see every day.
Yeah, well, actually, some of them are, and that's the beautiful part about it. You are literally getting to kind of see at a macro and micro scale how shapes around us in the universe are constructed. And we'll be doing a lot more data visualization and graphing and modeling with Turtle in the future, because now we can. This opens up probably more than most of the projects that I'm involved in. Turtle itself and Turtle and the HTML, with the way they work together, opens up just a huge territory for people to use PowerShell. We can now use it for much more real world modeling and data visualization and essentially hard math. So yeah, it's really, really cool. And ideally will make PowerShell a more attractive language to, many people, young and old. On the young side, I hope people get inspired to program through this and learn tech. On the old side, I hope various people who underestimate PowerShell or don't really know what it's capable of can kind of take one look at this and go, hey, maybe I will actually give this language a bit more of a try. You have this beautiful web page with this many lines of code. In this case, this is coming all for free by having a really, really detailed set of examples. So I'm literally just writing good examples and I'm getting this whole beautiful page that at this point is up to almost 2 megabytes of SVGs, which, considering that SVGs are just storing 3 things per string or per point, an L or an M and an X and a Y coordinate, that's a lot of points. This is a web page almost entirely made of beautiful images and instructions of how to make beautiful images. And it's still smaller than most MP3s. It's probably smaller than a photo you take with your phone. And it is, this is one of those, you cannot really see how beautiful it is without visiting the website. And that's going to be psturtle.com/commands/get-turtle. Going to be putting a lot more on that site in the future. But yeah, this is a very dynamic page. The way that you're going to see this animation, even if you're watching a recorded video, is going to be a lot more interpolated, a lot slower than it will be if you go to this page, where you're getting it basically as fast as the computer can render it. So this is a fantastic way to do high resolution animation and beautiful things. And just to make one other point on that bit clear, if I wanted to make an entire animated video, okay, just thinking like a turtle for a second. All right, so I can draw a beautiful background. That's one thing I can do with the turtle. And if I have any number of turtles in the foreground, well, if I know how big you are and at what position you are, I can tell when you intersect. Cool, I don't actually need to do that for most animations, so let's just worry about, how what layer you're on. I can give you that with the z-index. Cool. If I wanted to draw your movement, the movement of two characters on a screen, that's two turtles moving towards each other, presumably, or away from each other in two-dimensional space. It's very easy to visualize in your mind's eye, and it should be just as easy to program. I guess I kind of want to underline that point towards the end. I'm really trying to demystify graphics programming along the way. The joy of PowerShell is taking these things that are very, very complicated, if you have to look under the hood, and turning them into very easy to use commands. And if they're built entirely in scripts, it's really easy to open the hood and see how they work. But anybody can just use these really easy commands. And you can go through the learning process of how to work with a thing very interactively and intuitively. That's the great thing about PowerShell, period. You can learn how to program in that shell, right? And now we can learn how to program any graphical image inside of PowerShell, and beautiful high resolution animations inside of PowerShell. And not too long from now, great data visualization inside of PowerShell. And probably not too long after that, great animation of multiple entities to be able to do a whole animated show in PowerShell. And probably not too long after that, turtles in 3D.
I'm liking it, man. You're cooking us some good stuff, man. You're raising the ceiling of what is possible in PowerShell, and I think you're pretty good at it. But I have a candid question. I have two questions left.
All right.
One, how much was AI helping you along the way? Because I imagine for some of this mathy stuff, probably super simple to spit out a quick little equation for you. Were you going that route, or were you just like, it's kind of easy once you learn about pi, I can kind of figure this out?
Not too much. There was a early prototype that I had written just as like a single PS object. Just basically as one, new object, PS object, add member this, add member that, add member that, until I had, a more cool working turtle. And I did that in VS Code on my main desktop, and Copilot was, helpful in the vibe coding a little bit. Most of the dev work I've done for this particular turtle has been on my Raspberry Pi, or one of my Raspberry Pis. And there are a couple of reasons for this. The short, long one is I'm trying to build a really nice, graphical screen, and this will be really helpful for that. But the other thing is I wanted to make sure that it was performant enough. Like I would feel the performance pains of Turtle more on an underpowered device. And most of the dev work on that has not been very influenced by AI because of it, because I don't have Copilot set up on that one. So yeah, does that make sense? Answer the question.
Boom. Perfect. James, my last question. People have loved it. They say turtles. They can tell that you have a pretty advanced perspective. They've probably heard you on here before, and you're giving talks all the time. Pacific PowerShell User Group. But where can people find more from you? Where can we find you on social media? We want to stay in touch. We want to see your upcoming presentations.
Cool.
Where you
I
at?
am Mr. PowerShell on Blue Sky. And you can also visit mrpowershell.com, actually mrpowershell.com on Blue Sky. You can also visit mrpowershell.com. I am Start Automating on GitHub. So you can go to github.com/startautomating.
Yep.
And you can also check out some of the work that I've been doing with Turtle under the PowerShell web org, and we should talk a little bit more about this, but if you want to help with PowerShell and web development, we are gathering people and building fun projects. So that's where this particular project has been published.
Oh, nice.
Yeah.
I'll have links to all that in the show notes as well, so people can follow along and get connected, get contributing.
Yeah,
Get out
and
there.
two quick little other plugs. One, just in terms of trying to set for the community. Support is something that I think the community should be doing more of. I think that there are a lot of people that might give a little bit of Patreon to somebody who writes some YouTube or makes some YouTube, but they aren't doing the same for somebody who builds code that they use.
Yeah.
It would be great if you sponsor people whose work you use on GitHub, just
Absolutely.
as a general rule. And if you want to do that out of the kindness of your heart to anybody, that would be fantastic. If you want to do it to me, I would be doubly appreciative. Maybe I can kind of come up with some goodies to give. And the other one is I have been consulting for quite a while, and that means I am perpetually looking for the next cool PowerShell project to work on. If you've got one, let me know. Please reach out under one of those mediums.
You do know how to code PowerShell. I can confirm that in a way that legitimately not many people on this earth can. This is a very small table.
I like to hope so. But yeah,
I talk to a lot of people who write PowerShell. I'd say so.
I do try to keep growing the pie. And I think that this particular project and set of understandings, again, that I can make any web page just by redirecting content, and I can draw any image just by imagining I'm a turtle holding a pen, moving around a plane. All right. So those two things open up so much of the world for us that I believe it's going to be a very exciting time for PowerShell in the next few years. So I look forward to all of the new people that discover PowerShell because these sorts of things are available and fall in love with it. And if you have people that that don't know what PowerShell is, this is a great module to kind of show it off to them and help them understand. It's also, if you have people that are just kind of curious about programming or even just about art and building that computationally, please show them this. This is a great thing to help peel back a few layers of the universe and forge bonds and learn stuff. It is truly turtles all the way down, and it's a blast. So enjoy the turtles in a PowerShell. Thank you very much.
Powerful message, man. Thank you for joining us. And thank you, everybody out there, for listening. Walk safe, drive safe, all that stuff. Leave us a like, comment, subscribe. Check out PowerShell Wednesdays every single Wednesday at 2 p.m. Eastern. Literally every single Wednesday. Please come along. Let us know what content you want. James, appreciate you joining us for PowerShell Wednesday and now a PowerShell podcast. And I'm sure we'll be in touch in the coming months, and we'll have to get you on here again. So you have a lot of code, a lot of projects, a lot of topics we could talk about. Today we talked turtles.
Yeah, but it seemed like a fun talk.
I enjoyed it. I think there's a lot to glean here. Maybe people have to revisit it. Maybe it's the kind of thing. I think there's a lot of different things to take away for different people who are maybe at different stages of understanding this kind of odd IT thing, because there's so much stuff to learn there, but there's a lot of patterns that kind of go across different technologies and things you can learn from, I guess, in your case, looking in the past, right? So it's fun stuff. I mean, we're learning forever. That's what we're going to be doing in this career. So whenever we can find opportunities to make these kind of maybe some bigger observations, maybe feel like we're getting some kind of insight, I say have fun with that. I really enjoy the learning process of being in IT forever and seeing how things play out and seeing when new technologies come out. And I think for me, this kind of plays along with that. Have fun, let your brain enjoy it. You got to where you are in your career because you probably, hopefully, enjoy learning. And if you're listening to this an hour in, you probably enjoy maybe similar stuff to us. So let your brain geek out a little bit. Have some fun with turtles and PowerShell. And is that just install module turtle?
That is just install module turtle. And it is
Boom.
being pretty routinely updated. So keep checking
3 hours
back.
ago.
Yeah. I just, did some performance improvements. So at least I hope there are improvements. Time will tell.
Study his code too, I'd say. Like, look at the actual code. If you're at the level where you've maybe written a couple scripts, there's some things you can learn there for sure.
Yeah. And I will be actually continuing to grow out psturtle.com as a website and home for all of this stuff, because this is a huge discovery journey. Even if I can make the path of descent easy, even if I can easily move our turtle from point to point and rotation to rotation, there's still a lot of points to cover and rotations to make and, understanding to get. So I want to make this a very approachable website for both use of Turtle and constructing of pages on top of PowerShell. And it is really just beginning that. So this is a very, very young module, but it is a very cool module, and it is getting cooler by the day, sometimes literally.
Yes, exactly. I was about to say that. So awesome, James. We'll stay in touch and take care, everybody. Till next time.
Thanks for listening to the PowerShell Podcast. The PowerShell Podcast is a PDQ production, making device management simple, secure, and pretty damn quick.